Hello everyone! This is the second installment of my challenge to beat Minecraft solely by writing Lua scripts, and tangible progress is still largely out of reach. Despite my rough start to the challenge, I have a plan for moving forward. To do so, I need more turtles. Turtles and their tools are made of materials dug from the ground, like redstone, iron, and diamonds. Thus, my best option is to start a quarry with the one turtle I do have. To do that, I need fuel to run it, which requires a tree farm. To farm trees, I need more building material to expand my seaside platform. I have a program that can dig box-shaped holes already, so I put it to work gathering dirt and cobblestone. However, I realize along the way that it still has some bugs that need working out. While it works well enough for now, I'll have to give it the same treatment later as the platform building program from last episode. In the meantime, I realize I can't have a tree farm without saplings, so I cut down trees until night falls. At this point, my neighbors overheard my deliberations on building a tree farm and dropped by to express their disagreement. Instead, they suggested I should invest in the housing market since property value is through the roof right now, if you know what I mean. They aren't happy when I tell them I want as small a loan as possible and that I want to pay it off in 10 years, so I sit in a cave for a while as they pretend to reconsider. Once morning comes, I decide that some investment in real estate won't be such a bad idea after all, and have my turtle build me a beachfront apartment, in the form of a wooden box because I'm still broke. As I build, I get distracted by trying to make a program that can place rows of blocks for me. What distracted me was learning how to use ... a value hinted at last episode but not yet explained. This value is called a var expression, short for variable argument expression. It has multiple uses, but the use I'm concerned with is calling a function or program. When either of these is called with a collection of arguments, all of them will be packaged up in this value. They can be accessed in two ways. First, one can equate several variables to the first few elements of the var expression using multiple assignment, that is, an equal sign and a handful of commas. Second, one can also create a table from the var expression by placing it in some brackets. I choose to use the first method for my purposes since I know how many arguments I'll be calling my programs with every time. Unfortunately, my education took up the whole day. More phantoms, loan sharks, arrive, and with only 3 hearts to my name, I have to take shelter and wait them out. After a few minutes, I can play again, and my avant-garde architecture goes up without a hitch. All it needs now are a couple of doors. I add the door recipe to my furnace crafting program and place the doors down. Finally, I have basic shelter. The doors come with a catch, however. On my own, I can't open them. This is because turtles can output redstone signals which can open doors. This means that via my challenge's first rule, if the turtle can do it, it must, I can't open doors by hand. Hopefully I never get stuck behind a door without my turtle, right? However, I'm not worried about it right now, so I experiment briefly with opening doors with my turtle, then switch to rewriting my box digging program. All I have time for at the end of this recording is to write some pseudocode. Pseudo means fake, so pseudocode is fake code, or an idea for a program that's not actually written in code. Pseudocode can range anywhere from plain English to statements that look like they're already code but aren't quite. The use of pseudocode helps programmers to think through their ideas before they have to worry about specific syntax, and it also allows programmers to share ideas with one another across languages. Here, I use it so that I can think through what steps I want my box digging program to take before I actually write it. I spend the entirety of my next recording working on my box digging program. Other than the var expression, this program uses one new tool, the modulus operator. The modulus extracts only the remainder of a long division operation. For example, 7 divided by 2 is 3, with a remainder of 1. Thus, 7 mod 2 is 1. This is important to my program because I want my turtle to act differently depending on how tall the room is that it has been asked to dig. The turtle can dig 3 blocks vertically at a time, so if a room's height happens to be a multiple of 3, its job is simple. Just dig however many 3-block tall layers it takes to get to either the top or bottom of it. In this case, the height's mod 3 is 0, since dividing it by 3 has no remainder. This changes if the room has a height that isn't a multiple of 3. In that case, the modulus of the height is either 1 or 2. This means that the last layer the turtle digs must be either 1 or 2 blocks tall instead of 3, and it has to be repositioned accordingly. By the beginning of my next recording, I finished my first prototype of Digbox and take a break to solve what I think will be a much simpler problem. opening my door. I already know I can use redstone signals for it, so I whipped up a program that has my turtle apply a redstone signal to the wall next to the door so I can walk through. Then it mines the wall, walks through, and replaces it on the other side. I go ahead and test it right there and then because what could possibly go wrong? As you can see, this led to me getting locked out of my beachfront apartment since I ran the program with no block in front of the turtle. This meant no redstone signal was passed to the wall, the door never opened, and my turtle locked itself inside. So if I can't open the door, now what? Is the run over? Must I break my own rules? No. Instead, I just need to trick one of my spotty green neighbors into doing some demolition work for me. This didn't quite work the first time since the first foreman I contracted with brought 2 of his lawyers with him to question the terms of the agreement he just signed, after demolishing only the corner of my wall when he withdrew his services. However, the second foreman I contacted didn't read the fine print and demolished my wall without hesitation. Now I just need to ensure that this soft lock will never happen again. To do that, I need a wall design that will allow me to access my turtle from either side of it, but still provide sufficient protection against monsters. After accounting for skeletons and little zombies, the best compromise of accessibility and defense I could come up with used slabs as the bottom layer and upside-down stairs as the next layer up. This doesn't block projectiles, but does block my line of sight with most mobs, causing them to forget about me. It also is a small enough gap that baby zombies can't fit through it. To actually build it, though, I need to understand how turtles place stairs and slabs. Their placement rules are similar to players. If a block is 2 blocks away in a given placement direction, that is, front, top, or bottom, the stair or slab will be placed as if the player clicked that block. However, if there is no block 2 blocks away, the turtle will place the stair or slab as if it clicked on itself. The exception to this is that stairs will always face towards the turtle, not away from it. Knowing these rules will let me build my wall in the other world. Before I can implement the new wall structure, though, I need to add more crafting recipes to my turtle. So far, everything I've needed to craft only uses 1 material at a time, so I just added them to my furnace crafting program and renamed the program to Craft Homo, short for homogeneous, a fancy word that means it's the same everywhere. Now, after wasting much of my wood on buttons, I can craft stairs and slabs, and several at a time. With my new materials, I finish my front wall. As part of the process, I update my row building function to have a little more flexibility, such as allowing me to pick which direction the turtle will place blocks in. Once the wall is done, I update my door opening program to have the turtle apply redstone power directly to the door instead of the block next to it. If this feature was included in the first place, I wouldn't have gotten soft locked. My building and crafting efforts used up my supply of wood, so I took to more deforestation to solve that problem. This would kill 2 birds with 1 stone, actually, since I needed to clear the trees above where my quarry would be in order to start digging anyway. As promised from last episode, I downloaded a replay mod to showcase this, so I hope you enjoy the montage! After night falls, I try something else I learned from my creative testing. Turtles can attack mobs even when they are not holding swords. I try this on a drowned, and learned that running circles around my turtle trying to time its attacks correctly was absolutely not going to cut it for combat. Instead, I resort to leaving the drowned in the ocean, like I have hitherto done with other monsters. Once peace is restored, I think for a moment. In order to run either a quarry or a tree farm, I'll need storage. I can easily store and retrieve items in a chest using the turtle.drop and turtle.suck commands, but those commands aren't precise enough. I want my turtles to be able to make decisions based on chest's contents, and to do that, I'll need to learn some new programming devices. I switched my test world and start studying. The first thing I had to do was refresh myself on how to write data to a text file. To do this, I would need to use the fs.open commands to open the file, and later fs.close to close it. Here, fs is short for File System, and true to its name, its commands are used for interacting with files on the turtle or computer you're working with. While writing this script, I got curious. I knew I could use the fs.open commands to return a value, named file here, that I can use to interact with the file via reading or writing commands. But what is file? What is fs? What's going on when I type things like turtle.forward or fs.open? How does it all actually work? With the combined powers of a book called Programming in Lua and ChatGPT, I dove down a programming rabbit hole and got the answers. First, anytime you see a dot in Lua, that's a reference to an element of a table, specifically a key with a name given by the expression after the dot. Tables in Lua can contain functions. Therefore, a function inside a table can be called by referencing it using the table it's stored in. Thus, fs.open means take these provided arguments to the table called fs. Look in this table for the function referred to by the key named open. Use the arguments to run the function contained therein and return the result. The reason why I have to name a variable file to use the fs.open command is because the output of fs.open is another table. I can name this table whatever I would like, but file is the name suggested by the Computercraft wiki. This table contains some functions that edit the file I'm writing to. When I call file.write, which is the function within the table file associated with key write, it writes a provided string to that file. When discussing functions in tables, Programming in Lua says that this is, quote, almost what we call a method, unquote. That statement made me curious, so I asked ChatGPT what it meant. It told me that a method is a function in a table designed to act on other elements of that same table. This is Lua's approach to programming objects. An object in programming is a group of properties that keep track of something you want to be represented in your program. For example, you could consider a jar of peanut butter to be an object with parameters like its volume, percentage remaining, calorie content, nutrition, price, and more. If you wanted to show that someone ate some peanut butter out of that jar, you would need to edit the percentage remaining property of that object. This can either be done by direct assignment or through a method. In other programming languages, a method is a function that's defined as part of a class. A class is a script that creates objects and stores functions that can be used on the objects that it makes. For example, a class that describes what can be done with a jar of peanut butter could include functions that describe someone eating peanut butter from the jar, decreasing its percentage remaining, or someone adding or removing its lid, changing its moisture levels or exposure to pests. However, Lua has neither objects nor classes. Instead, it has tables and, unofficially, methods. Tables act both like objects and classes, since one table can be made to represent an object or class, then copied to other tables to make them act in the same way. Coming full circle, this means that the line file equals fs.open with its arguments finds the global table called fs, runs its open command, then spits out another table full of functions that it created using the arguments you gave it. That new table of functions can be used to work with your file. Finally, global tables like fs or turtle in Lua are called standard libraries, or APIs. While some of the ones mentioned here come from Computercraft and others from Lua itself, both are included in every Computercraft program and can be called from at any time. Specifically, API stands for Application Programming Interface, which means that these commands allow users like us to control what Lua is doing without needing to know exactly how they work. If we did want to know that, we would need to write in a lower level language, like C or Rust. In the case of Computercraft, the commands we use interface between Lua, our scripting language, and Java, the actual language Minecraft is written in order to make things happen in-game. Phew! That was a lot. Let's return to Minecraft. Despite not knowing their inner workings at the time, I used fs.open and fs.filehandle.write to write the results of a turtle.inspect call to a text file, and found that while it describes the chest, it did not describe its inventory. I would need a new API for that. This API is called Peripheral. Its commands help computers and turtles to interact with certain blocks around them, such as inventories or monitors. To get started, I run some code I found on the Computercraft wiki that interacts with chests. This code does something very similar to opening files from earlier. When I call chest equals peripheral.find, it uses the peripheral.find method to return a table of functions that can interact with that particular chest. The remainder of this code snippet prints the contents of that chest by iterating through its slots. More on peripherals in a moment. Next, I want to customize the printed output of this snippet. To do that, I need to understand how to use the string.format method. Its purpose is to create strings out of several variables and text snippets at once, and to format each variable according to specifications set by the user. To substitute a variable, one just has to write % along with a letter. Here, D means decimal and S means string. Once the string is written, the user tells the program which variables to assign to each % mark by feeding those variables to string.format as arguments. In my case, all I wanted to do was make each name more concise by removing Minecraft : from it with the string.gsub method, which replaces phrases in strings. Here I use a new kind of shorthand unique to methods, the colon. Any method that takes its attached value as an argument can be called in two ways. The first way is the standard way, providing it as the first argument in parentheses. For example, yourTable.yourMethod with yourTable as the first argument. The second way is with a colon. The colon makes Lua assume that the first argument of the call is the value that the method is acting on. This would change our example to just yourTable::yourMethod. For our string, this will change string.gsub, yourString, to just yourString::gsub. Therefore, when you see me use colons in my code, just remember that it's shorthand for another argument. One more aside. If you were paying attention earlier, you would have recalled that a method acts on a table and takes that table as an argument. This is true, but functions and tables in Lua are often called methods in both the Lua and Computercraft documentation, regardless of whether they follow that specific format or not. Realizing this difference led me to ask how it is that strings act like tables in that they can be called with methods. The answer is that they all share a metatable. Metatables are powerful devices that I will explain further in another episode, but for now, the metatable attached to strings just says to refer to the global table named string whenever you attempt to index a string like a table. Now back to Minecraft. Having edited the inventory printing program from the wiki to my liking, I now have a program in my test world that can print the contents of a chest without me having to open it. Excellent! Now I need to learn how to deposit and withdraw items from it. This was harder than expected. You see, the table, returned by peripheral.wrap for an inventory, has two functions that can move items: push items and pull items. Both of them do exactly what you would expect in most ways, since the user can specify which slot of an inventory to pull from and how many items to pull. The catch is that these functions can only deliver items to other peripherals. A turtle can't wrap itself as a peripheral without some help from internet equipments I can't craft yet, so I need a way around this. For now, I found a solution. I simply have to add another chest above or below my turtle and deposit my withdrawn items into it. Then I can command my turtle to take those items with the turtle.suckup or turtle.suckdown commands. This was enough knowledge for me to return to my survival world and write a manual inventory management program. In other words, a way for me to use chests. After moving my two previous furnaces to the new house and setting them up for more fuel, I put down a chest and began scripting. I already explained all of the concepts it uses, so the final script can be summarized as follows. The program runs in a loop for as many times as the user desires. On each iteration, it lists the contents of the chest in front of the turtle, then asks me whether I'd like to insert or extract items and how many. If I insert items, it simply selects the appropriate slot in the turtle's inventory and deposits the requested amount. If I extract items, it pulls the requested number of items from the front chest and deposits them into the bottom chest. Then the turtle can pull those items from the bottom chest into its inventory. Finally, if the front chest is empty, it simply displays empty instead of nothing. This last step confused me for a while because I did not know how to determine if a table was empty. This is because Lua and MATLAB are very different from each other. Most of my programming experience thus far is in MATLAB, a high-level language designed for scientific computation. Comparing tables, called arrays, in MATLAB is terrifically easy, requiring only a double equals sign or a specialized function, isEmpty, to differentiate a blank array from a populated one. This is because MATLAB stands for Matrix Laboratory, and the entire purpose of the language is to expedite the creation and use of vectors and matrices. However, Lua is not like MATLAB. When comparing two different tables in Lua, the results will always be false. This is because each table in Lua has a unique identity regardless of which variables are used to point to it. When comparing tables, Lua doesn't compare the table's contents at all, only their unique identities in memory. This means that I need another way to find out if a table is empty. Luckily, the next function comes to the rescue. Given a table and key as arguments, next outputs the next key value pair. If there are no more key value pairs, it outputs nil. If it is only provided a table and no key as an argument, it outputs the first key value pair. That means that if next is given an empty table, it will look for the first key value pair, find nothing, and output nil. Bingo! With this, I can have a chest display a different message when it has no inventory. After some final tests, I determine the program works for what I need it for and end my recording. I'm out of time for now. The tree farm will just have to wait until next time. Thanks for watching!